Hi there, and welcome to a Papetti Math YouTube video tutorial where I'm going to be teaching you, yes, you, Algebra 1. And in this video, we're going to be looking at a continuation of linear functions where it says a function is said to be linear if both of its variables have a highest degree or exponent of 1. So, decide if each of the following is linear or nonlinear. So we're going to be looking at the variables, and if they each have an exponent of 1, so let's remind us what an exponent of 1 looks like. If we have 4 to the first power, how can we rewrite 4 to the first power? Well, 4 to the first power is just 4. 7 to the first power, what does that equal? Oh, that's just 7. So x to the first power is just x. So we're not necessarily going to see a 1 as an exponent. We're just going to see a variable that doesn't have an exponent on it. So that's what we're looking for. If we see an x with a 2 on it, that's higher than a first degree polynomial. So we're going to focus on just looking for if it has an exponent of 1, it's linear. If it has a higher exponent than 1 or lower exponent than 1, then it's nonlinear. So let's take a look at part A. Y equals 2x minus 6. Well, this looks like what we were just looking at in the previous exercise with y equals mx plus b. And again, this is y to the first and 2x to the first. This is linear because that's the highest degree of 1. Okay, in part B, we have 3x minus 5y equals 7. So again, the x variable has an exponent of 1. The y variable has an exponent of 1. So yes, this one is linear as well because it has a highest degree or exponent of 1. In part C, y has an exponent of 1, but the x has an exponent of 2. So this one has a degree of 2, and that's higher than a degree of 1. So this one is nonlinear because the x is squared. That's not allowed in a linear function. Now again, we have a whole bunch of fractions here, but don't let the fractions throw you off because again, just look at the y variable. It's got an exponent of 1, and the x variable, exponent of 1, which makes that one linear. X squared plus y squared, right away you see a greater exponent on both the x and the y variables. So this one is nonlinear. This is actually a circle right here. When you square both the x and the y values, you'll get a circle. And in this last one, we're going to look at our variables. We have a x exponent of 1, y exponent of 1, x exponent of 1. No matter how many x's you have in this equation, they are all separated by addition and subtraction, and they all have a highest exponent of 1. So guess what? That one there is linear. So basically, you're looking for if the x and the y are by themselves. If they have exponents connected to them, it's not linear. Otherwise, it is linear. Now, if this video was helpful in distinguishing between these functions, if they were linear or nonlinear, give the video a thumbs up to let me know that I helped you out, and you're ready for exercise number 3 now. Good luck.